Hey there and welcome. Today we're going to be covering Contextual Hybrid RAG, which is a very powerful RAG strategy that combines both contextual RAG with hybrid search, and this combination enables for not only contextual retrievals but more relevant ones, especially if you're looking for more specific data within a knowledge base. So I would definitely recommend for you to understand this very well, especially if you're somebody that works with RAG technology in general. But before I actually get to explaining what contextual hybrid RAG is and walk you through this workflow here, as you can see, I set this as level 3. So what I want to do first is I want to first walk you guys through these two levels at a high level so that once you get to contextual hybrid RAG, it would make more sense, okay? And for this, what I want to do is I want to head to Excalibur because that's where I have all these materials ready. And let's start with traditional RAG. And traditional RAG is super straightforward, right? We have a document that we want to convert into a knowledge store or into a knowledge base. So what we would do is we would convert this document into chunks, and in this case, chunks of text. And then we will get that chunks and convert them into their vector representation, like the one we can see here represented in this diagram. And then we will just take these vector representations or vector embeddings and insert it into a vector store. And for those of you who don't know what a vector store is, it's essentially a special database that stores data within a high dimensional plane based on their semantic meaning. So you would have words like cats, dogs, mice being placed close to each other within a vector store because they're semantically similar, not because of the letters that they contain being similar, right? In this case, they are not similar in any way, but they are still positioned close to each other because of the meaning that they hold. So that is what a vector store is, and that is pretty much how traditional RAG works in general, and it is a very powerful strategy, right? However, while traditional RAG is great at fetching semantically relevant data, it is actually not good at fetching contextual ones. So let me actually explain to you with an example here. So our scenario here is a knowledge base that contains quarterly earnings reports for various companies. And let's say in our knowledge base, we have this particular chunk that says revenue grew by 3% over the previous quarter. That does not include any kind of context, right? We don't know, first of all, which company this is for or which year or even which quarter this belongs to. But let's say now a user query says, what was the revenue growth for Acme Corp in Q2 2019? Because the way that RAG works is by looking for semantically matching data, and again, because these two are similar, this one talks about revenue growth, this one also talks about revenue growth, so they are semantically similar, right? When we run this query in a traditional RAG, that RAG system can actually return to us this chunk here, which again could be from any quarter, any company, or any year, right? This would unfortunately cause our LLM to hallucinate, or actually it's not going to cause our LLM to hallucinate, but because it's being fed false context, it is going to refer to that in order to respond to the user query, and as a result, we get something that is not accurate. And so that is a problem with the traditional RAG system, and the way we solve that is by using this strategy called contextual RAG. And looking at contextual RAG, the way it works is very similar to traditional RAG, but we just add an additional layer to the way that we ingest data. So we have, again, our document. We split that document into chunks of text. And then after splitting this document into chunks of text, what we will do later then is we would actually combine each of these chunks with the whole document and then pass this document plus chunk to an LLM for it to actually compare the chunk to the whole document in order to add context to it, right? So for example, in our case here where it says revenue grew by 3% over the previous quarter, this was going to be the chunk. And in this case, our LLM would compare this chunk with the whole document, and it would be able to find to which company, which quarter, and which year this particular chunk belongs to. And it would basically create contextualized chunk out of that, which we are seeing here now. So we take in our document plus chunk, pass it to an LLM. The LLM basically processes this, generates a contextualized chunk for us for each of them, and then we do the exact same thing as we did with our traditional RAG, where we convert this one now here into its vector representation, and then we'll add it into a vector store just like we did for our traditional RAG, right? And when we look at our scenario, we have this improved chunk in the database. It is the same chunk here, but now it just has context added to it. So we're saying, hey, in Q3 2016, Acme Corp's revenue grew by 3% over the previous quarter. So when the user this time asks for what was the revenue growth for Acme Corp in Q2 2019, and because this time the database is going to return the same chunk but with its context, the LLM will be able to compare it to the user's query and understand that this is not what the user is looking for. Therefore, it prevents the LLM from providing the wrong answer. And that is exactly what Contextual RAG aims to solve, and it does it very well. Actually, we are also going to be looking at that once I walk you through this workflow and see how that actually works. All right, so while we are now solving the contextual part of the problem by providing contextualized chunks to our LLM, preventing it from generating false information as a response, there's actually another problem that we are facing here, which you probably already noticed, right? In our query, we are looking for Acme Corp in Q2 2019, which is a specific kind of information that we are looking for within a knowledge base. This could have also been something like a product code, or let's say a model number for a mobile phone if you're trying to, let's say, troubleshoot a particular mobile phone based on its model, right? So in cases where we are looking for more specific data based on keywords like these, Acme Corp and Q2 2019, our query might actually return chunks that are like the one we are seeing here that is related to Q3 2016, for example. Again, Contextual RAG is at least going to prevent us from getting false information, but it is not going to guarantee us to actually get the relevant chunks when we query the database, right? So in cases where we want to, again, look for more specific data using keywords, product code, or again, model number of something, that is when using Contextual Hybrid RAG is actually going to be the ultimate combo that we are looking for. So for this, let's understand exactly how this works. And from this part all the way here, it's actually going to be the same thing, right? We convert the document into chunks of text, and then these chunks of text, we're going to convert into documents and chunks, and then pass them to an LLM for each of them, convert them to contextualized chunks. And out of these contextualized chunks, we are going to convert it into dense vector embeddings, which is the embedding strategy for RAG, right? So we convert it to vector embeddings, and then we add it into a dense vector store. This part is basically exact same thing as this part. But now what's different with hybrid search, just like its name implies, we are also using another algorithm, and for that we are using another kind of embeddings as well, which is called sparse vector embeddings. And the logic under the algorithms that generate these kinds of vectors is actually based on keyword matching. So you can think of this as a traditional search where it's going to assign points to data based on the number of letters that repeat itself or the words that repeat within a sentence, right? That is in contrast to how dense vector embeddings work, or how RAG works in general, where we are actually storing data based on its semantic meaning. And so what we're doing here essentially with hybrid RAG is we are combining the best from two worlds, where we have semantically fetched data and also keyword based fetched data, right? And having something like this will just be very powerful for instances where we are looking for specific keywords. So what's going to happen is we are going to generate this dense vector embeddings out of our chunks, or out of our contextualized chunks in this case, but we are also going to generate its sparse vector embeddings representation, and then we are going to store them separately in two different indexes. We have a dense vector store and we have a sparse vector store. And this was basically the storing part of things. The second part of this workflow is the part where we are actually querying data from our vector stores. All right, so first we have the query prepared, right? And this query gets converted into its dense vector representation and also its sparse vector representation, of which then we individually query against these two vector stores using the corresponding vector types. And after that, we get the accumulated results from both of these vector stores, right? So you can think of this as these two coming from the dense vector store, for example, and these two up here coming from the sparse vector store. After that, what we're going to do is we are going to pass these results to a re-ranker model such as Cohere. And this re-ranking model, what it's going to do is it's going to look at both of these results and look at the scores for each of these items generated by each of these vector store types and run an algorithm on it to re-rank the results for us. And finally, we pass it to an LLM, and this LLM generates response to us based on the context it received from our hybrid RAG system, in this case, to generate a much more accurate response in the cases that we just saw above. So now let's take a look at the exact same example again, and this time we also include the other type of chunks that may be present in the database, right? So we got Q2 2019, Q3 2016, and we got our same user query, and the result is Contextual Hybrid RAG uses both dense vectors to understand the meaning of the question and sparse vectors to match exact terms like Q2 and Acme Corp. This ensures that the system retrieves the correct chunk in Q, this one basically here, right? And this approach delivers a precise and contextually relevant answer, solving both the context keyword relevance problems seen in earlier RAG approaches, and that is precisely why having contextual hybrid RAG implemented in your system can actually be very useful. All right, so now that we understand exactly how contextual hybrid RAG works, I am going to walk you through this workflow here that I have prepared on n8n, and in this case, I'm going to be implementing it in Pinecone just because my first two examples were implemented in that as well, right? And for those of you who don't know, I have another video where I cover contextual RAG in detail, so I'm gonna add a card to this video so that you can watch that if you would like to. But just know that we are going to be implementing this whole contextual RAG up to this point anyway in our contextual hybrid RAG. So you can see that from here all the way to here, we are doing the exact same thing where we are contextualizing our chunks, and we are only starting to do different things at this point where we want to generate sparse and dense vectors for it before actually adding it to Pinecone, right? And if you are using Supabase as your RAG provider, then I would highly recommend to watch AI Automator's video. They have a great video on this topic where they talk about how you can implement hybrid RAG in n8n using Supabase, which was also what inspired me to film this video. But in their case, they're only going to show you how to build hybrid RAG. So if you are using Supabase as your RAG provider, what you can do is you can watch that video to see how you can implement hybrid RAG using Supabase, and then just combine it with the contextual RAG part of this workflow, and you should be good to go. So with that out of the way, let's get started. So the first thing to note here is that unfortunately n8n does not provide us with a built-in way to run these hybrid searches, so we are not going to be able to use their built-in tools like the ones here or the ones here, and we would have to run custom HTTP requests to Pinecone ourselves in order to make this work. And this is the ingesting part, and this is the part where we are actually searching for the data from the knowledge base, right? So what I'm going to first do is I'm going to first walk you through these HTTP requests and set up my account so that you can see how we can actually set this guy up and make it so that we can have our pipeline here ready. Okay, the first thing what I'm going to do here is I'm going to head over to Pinecone, okay? And then I'm going to log in. And once you log in, the first thing you want to do is you want to head over to the API keys page and then create an API key. And once you do that, copy the API key, head over to this HTTP request node. What we're going to do here is set the method to post and set the URL to this one here. This is what we're going to be using in order to create our dense and sparse vectors. And once you do have this URL set, what we want to do now is you want to go to authentication, click on generic credential type. And after that, go to generic authentication type and select header auth. And once you do that, go down to the header auth drop down and create new credential. And for the name here, set as API key. And for the value here, just paste in the API key that you just copied from your Pinecone account. Once you do that, you basically have this part here ready. And after that, what we're going to do is we are going to set headers. In this case, we are setting the Pinecone API version to this one here. And also we are going to be setting a JSON body for our request. And this is what the JSON body looks like. We are using the multilingual E5 large model. And the reason to that is actually because when we go to their documentation, you can see that the embedding model that Pinecone hosts internally are these three here. So instead of using this multilingual E5 large, I could have also used OpenAI's embedding model, but in that case, I would have had to basically use this HTTP request node to target my OpenAI account and use their embeddings API. In this case, I want to keep things simple, so I'm just going to be using this model here for embedding. But if you want to use OpenAI's embeddings model, then you can definitely just do what I just said. And for the parameters, these are pretty much set by default. And for that, actually, if you go to their API reference, embed API reference, you can just go over here and copy their curl command. And once you do that and you head over to your HTTP request node and click on import curl and paste it there, these are actually going to be your default values anyway. And this inputs part here is what we're going to be seeing later in this video. So I'm just going to leave that out for now. And after that, we got our generate sparse vectors HTTP request node, which is going to be doing the exact same thing from the method being post, the URL being the same one, and setting our authentication values here, configuring it. And then we have the same headers, and also in our body, everything again is actually the exact same thing except for the model that we are setting here. And this time the model that we are using is for the sparse vectors creation. And again, if you go to their documentation here, you can actually see that this is the model that they are using. This is a sparse embedding model for converting text to sparse vectors for keyword or hybrid semantic keyword search. So that is exactly the model that we are using for our sparse vectors creation. And finally, once we have both of these ready, we have this code node to combine them together in order to create our final payload that we are going to later pass to this HTTP request node to store it into our vector store. And some of you might actually be confused by the fact that, and when I was explaining in this tutorial here or in this diagram here, I said these get inserted into separate vector stores, and they also get queried individually, right? But in our case, the reason we are only using a single HTTP request is because Pinecone actually provides us a way to use a single vector store to basically run hybrid search. And for the re-ranking part, it's going to be using its own internal algorithm, which I'm not really sure how they what they're using for that, but basically we will not have to re-rank it ourselves. And so going back to the HTTP request node, again, this time our method is set to post. And this URL here, if you notice, is a bit different, actually a lot more different compared to what we had previously. This thing here is actually the host URL for my index. So what we're going to have to do right now is you'll have to go to our Pinecone account again. I'm going to click on database. I'm going to click on create an index, and I'm going to name this hybrid RAG tutorial. Okay. And then in the configurations part, what we're going to do is we're going to click on custom settings. And for the dimension, we're going to be using 1024. And the reason we are using 1024 here, because again, we are using their multilingual E5 large model, which has dimension of 1024. But if you were to use OpenAI's embedding, then you would have to set this dimension to the number that that model requires. Right, in our case, it's 1024. For the metric, we'll have to use dot product, because apparently for this type of hybrid search in Pinecone, dot product is the only combination or is the only metric that we can use for it. So once we do have this ready, we can just click on create index. This is going to create our index for us. And once it does create our index, you can see now that we actually have a host link or a host URL generated for this particular index. And that is exactly what we are going to add into our HTTP request node here. And that's what I'm going to do. I'm going to click on paste here. Okay. And now the final outcome or the final result is the host URL and then /vectors/absurd. And that's exactly what we are doing. That authentication, again, the same configuration, sending headers. The send headers is the same thing. We got Pinecone API version, value 2025-01. Again, the same thing. For the JSON body, this time we are passing in vectors and namespace. We are going to be looking at what these are once we actually execute this workflow. And so we just looked at the ingestion part of this workflow here. Let's take a look at the part where we are actually going to query this vector store. Here at first, we have the generate sparse vectors HTTP request node, which does the exact same thing as what we have here. We are essentially just converting our query this time into its dense vector representation. Or sorry, apparently I put sparse vectors here first. And in the second one here, we have the same exact one as we had here for generating dense vectors. So we are going to be basically generating the dense vectors this time for our query instead of the items that or the chunks that we are trying to insert into the knowledge base. And Once we have both of these prepared, we also are using the same exact code node to convert them into a payload that we can later pass into our query vector store HTTP request that's going to query the index, right? And I will also have to update this URL here to the new one that we just created, right? The new index we just created. Once I do that, this is the result we got. So this is the result that we get. We got the URL and slash query. Then I'm gonna go down and you can see the send headers is again the same thing. And for the send body, this time we're just passing in the payload that we get from this code node. And so now we are actually ready to execute this workflow because we have our index created and configured. So what I'm going to do now is I'm going to run this workflow, and once we are done running it, we are going to walk through step by step, understanding exactly what's happening in each of these nodes, all the way from contextualizing the chunks and then storing it into the vector store, and finally how we query it. Okay, so what I'm going to do is I'm going to click on test workflow now. This should grab the fiscal 2024 for NVIDIA. Let me just make sure that that is the case. So yes, second quarter fiscal 2024 PDF. And what we are doing here now is basically contextualizing chunks as we saw in these diagrams that I showed you guys just now. This is the part we are in within the workflow. We got the documents, and now we are passing the document along with the chunk to the LLM for it to generate contextualized chunks out of it. And after that, we're going to convert it into both dense vector embeddings and then sparse vector embeddings once it is complete. So I'm just going to let this process, and once it's done, we're going to be walking through step by step. But before that, I want to let you know that I'm going to be adding this whole workflow in my community. So once you're in here, actually, you can just head over to the classroom section, head over to all my builds, then click on Contextual Hybrid RAG. And when you scroll all the way down, you can find the resources to this, and one of the resources here is the template itself, so you can just come over here and download it. So we are currently at 24 members now, and the price is only $44 for the first 50 members as a courtesy to early joiners. And what you'll get inside is not only my templates, but also 3 live calls per week and n8n tech support by me. Apart from that, we have all the other things here that you can see. So definitely hoping to see you inside. But with that, let's go back to our workflow here, and it seems like it is complete, which is perfect. All right, so now that it is processed, let's actually take a look at the index that we just created and see what kind of data we have inside, right? So you can see here that we have all of these items populated. We should, I think, have 33 items, and there you go. You can see that we indeed have that. So what we have here are not only contextualized chunks, but they are also stored using sparse vectors, which enables us to run hybrid search against it, which is super cool. Apart from that, we have the file URL as metadata and the text here, okay? And we are also using namespace in order to categorize the type of data we are inserting into our index. In this case, we are using financial report, so that's the reason why we are setting the namespace to financial. Now, when we go back to our workflow, we can now walk through it step by step and understand exactly what's going on. First, we have our Google Drive trigger, and what it does is it simply goes into my Google Drive looking for this folder, and it gets triggered when a file is created. And in this case, what we have is the Q2, actually, let me just open it real quick. Second quarter fiscal 2024. This is the file that I added into my Google Drive, and this is what it downloaded. So what it did then was it took this file, it entered this loop here. This is basically saying for every item that this guy returns, execute this workflow once. And so then we have this CR namespace classifier for the same reasons that I mentioned just now, where it's gonna read the content of the report, and based on that, it's going to decide in our case if it's financial related or frequently asked question related data. And the prompts for this is pretty simple. We are just telling it to just decide what namespace this ingestion flow belongs to. Okay, and after that, we got contextual RAG file info here. We're just getting the file ID, file type, file URL, file title, and also the namespace that we just got as an output. Then we go into this Google Drive node that downloads the file for us, and then we enter this switch, and the switch is simply just checking the type of file it is, and according to that, it's going to output through one of these routes. In this case, it is a PDF, so it output from this route, and we are using different strategies to extract data from different kind of files, and that's what we are seeing here. And we go in here, we extract from PDF, then we convert it into this object here, and finally we are getting it again. Then what we have here is a recursive splitter, and this recursive splitter is doing exactly what these things here do. So we have this character splitter, right? And then we have another one, for example, we have this recursive character text splitter. This is exactly what we are replicating with our code node. Unfortunately, like I said, because we don't have a built-in way to do hybrid search, we also can't use these guys here. And because of that, I had to build my own recursive splitter for this use case. And this is what we have as a result. So the chunk size is 1000, the chunk overlap is 200. Then once we chunk the document, we are splitting it so that we can run and request in this LLM for each of the chunks that we have created. And in this case, we have 33 chunks. And what we are doing within this LLM is where something really cool happens. And this is where we are basically implementing contextualized RAG. And we are saying, hey, we are passing in a document. This is the whole document data, right? This is the whole fiscal 2024 report that we just downloaded from Google Drive. And then we are passing it the chunk. So we are saying, hey, here's the chunk we want to situate within the overall document. Passing in the chunk, comparing it to the document. We are saying, please provide a short and succinct context to situate this chunk within the document for improved search retrieval. Return the original chunk exactly as provided unless a correction is necessary. If the chunk contains an incomplete number, percentage, or entity, correct it using the full document. This can actually be very powerful as well, because sometimes you get faulty chunking where things can be split in the middle and you might again just have incomplete data. This is not a huge problem when you use the recursive text splitter strategy, but when you're using other strategies, you might want to definitely be careful of this. And this is exactly what we are solving using this contextualized RAG. And then we are also saying, if part of a sentence is cut off, reconstruct the missing words only if necessary for clarity. If the chunk is part of a table, include the complete table entry to maintain data integrity. Do not add any additional explanations or formatting beyond the required output. Fill in the following format, succinct context, and also the original chunk or corrected version if necessary, right? Your response should contain only the text that replaces these placeholders without including placeholder labels themselves. So we are saying, hey, don't add this, just replace these with the relevant information. And here is the result. So we got this document, we are passing in. So this is the prompt, how it looks once we have these data populated. And the output of this, we can check. You have this guy here. So we got summary of NVIDIA's Q2 fiscal 2024 financial highlights, which is perfect, exactly what we want, right? We can see that this is the context that's being added before this comma here, and semicolon here. And at the bottom, we have the exact same thing. The context is from here all the way here, telling exactly what this chunk is about. And it is, remember that if it finds anything that is being broken in the middle, let's say a table that's not complete, it is going to make sure to also include the table itself, like we have in this example here. And that's basically how it is for all the other items. And you can see how powerful this can be, especially in cases that require contextual relevance, which, going back to our Excalibur, this is exactly the part we are at right now, right? We are converting these into contextualized chunks, and this is the exact problem that we are solving. So this time when the query user asks for something like this, we are going to return chunks with their relevant context, which makes this super powerful. So at this point, we have our chunks contextualized. What we have done here is the set chunks set node, where I'm just changing this format. But in hindsight, this looks like I didn't actually have to do this. It's redundant, right? Since the output from the output from the LLM itself is already the exact same format. It's not going to do any harm, but it is redundant nonetheless. So what we are going to do after that is we're going to get these chunks, okay, again, redundantly reformatted chunks, and then pass it to this aggregate node. And this aggregate node is basically going to just accumulate all of these items here, which are 33 right now, into a single item. So we have a single array of objects called data, and this is what we are passing to this loop node here. And again, the batch size is set to 96 because that is how many numbers of items or chunks we are able to generate dense and sparse vectors out of, according to Pinecone's API specification. and that is why we are basically adding 96. Oh wow, nice. I just realized that I made a mistake. Remember I told you like this allows up to 96 items, but we are already aggregating the items here, so it doesn't matter how many items we have. Even if this was, let's say, 1000, aggregating this would have ended up with one item anyway, and this would have thrown an error if the number of items were higher than 96. So instead of adding the aggregate node here, I had to add it inside here so that we could actually aggregate it once it is inside, right? So in that case, let's say this outputted 500 items, and each time we entered this loop node, it would run 96 items. Those 96 items would then get aggregated and then be passed to these APIs here, and that would fix our problem. So it's super simple to fix, and the reason why it did not error right now is because of the fact that we only have 33 items. So don't worry about it. Once I walk you through this whole workflow and we look at how it works, I am going to just fix this quickly and show the final results to you, and I'm going to be uploading the fixed version to my premium community as well, so don't worry about it. But right now we have no problem, so let's take a look at what happened here. Right, first we are generating dance vectors, so we are back in the generate dance vectors node, and this time we have the inputs populated, right? And this is what inputs look like. Again, an array of objects with a field called text, and that is what we are passing to this URL here, and what it returned to us is the dance vector representations of our inputs, right? And then the next thing, we have the exact same thing here, passing in the input, but this time the only thing that's different is that we are generating sparse index out of our inputs, and this is the resulting output here. We got vector type set as sparse, and these are the values as so. And the next thing here is the code node where we combine all of these data together, and this is the format that we are returning it in. So for each of the vectors here, we are generating a unique ID that we are going to insert into our vector store. And for the values, we are passing in our dance vectors values. And for the sparse values, we are passing the result we got from the sparse vector HTTP request. And finally, we have another object that's called metadata. We are passing in the text here and also the file URL as a result. So this is how we were able to see the URL in our items. So the file URL and the text, and in your case you can add any other metadata that's relevant to you. And lastly, we are combining the output for this with the namespace. So we are basically saying which namespace are we planning to insert our vectors into. And because again, in our case, we inserted financial related data, the namespace we set was financial. And you might be wondering, why do we need namespace? The reason you should use namespace, especially if your company has a huge knowledge base, is to help it reduce noise, right? For example, a query may look for something related to, again, financial reports, or frequently asked questions, or technical data such as, let's say, troubleshooting a product or a device within your company. In that case, what we're doing with namespaces is we are removing noise. So if that question is clearly related to, let's say, FAQ, then just bring FAQ related data. If for example, if it's related to the financial reports, then definitely just return financial reports based data, so that you won't have to also search through the other kinds of data within your knowledge base. Hope that made sense. But yeah, and then finally, once we got all of these data prepared, we use this HTTP request node to upsert it into our index. Again, we are using our host URL here. We are setting our authentication. We got the send header set. And when we look at the JSON body, we are passing in the vectors and also the namespace we want to insert our vectors into. Then we post this. Once we do that, the result is what we see in our index here. So it's a success. Now the second step we're going to be looking at right now is going to be, how do we search this index? Because again, we are not going to be able to use these built-in tools since we are trying to do a hybrid search, and n8n does not provide a built-in way to do that. And in that case, what we're going to do is we're going to manually do it. And the way we do it is by, again, generating sparse vectors and dance vectors out of our query, and then combining them together, creating a payload that we want to send to our vector store. And this is what the payload looks like. We got namespace, vector, sparse vector, filter, top K20, include metadata. And this is the parts where we're basically preparing and getting the data together into this one single payload here, and we are returning it as data from this node. This gets passed to our query vector store node, and here we are sending that payload. So let's actually execute this. Okay, so we got this RAG agent here that is connected to this workflow, but this original workflow is in another in this canvas here. Okay, so what I did was I basically passed in this workflow as the tool node for this agent, and also gave it a short description saying this workflow has access to a RAG database, plus in the corresponding namespace and query. We can see inside our node here, or workflow here, we are asking for namespace and query as the input parameters. So let's head to our document. I'm actually going to look for something very specific. What is, let's say, up 26.6 points? Do we only have one? Okay, we only have one of this, right? So what is this related to? Up 26.6 points, since we're literally asking for keyword like question. So I'm going to say, go into my node here. I'm going to click on, and then I'm going to say, what is this related to within the document? I'm also going to say, use financial as namespace just in case. Then I'm going to click on test workflow, and let's see if the result is going to be returned. I mean, I'm pretty sure even if we didn't use hybrid RAG, in this case the agent would be able to answer since the document is very small. But what's important here is the ranking of the item that we are looking for within this query. Okay, so I'm going to click on tool, and when we look at this, let's actually just head over to the logs. That would look better. When we go in here and we edit up 26.6 points, you can see that the first thing that comes to us as a result is directly this number here, which is awesome. And when we look at the answer it provided us with, this information is related to NVIDIA's financial performance metrics for the second quarter of fiscal 2024, gross margin, operating expenses, operating income, which when we look at it is exactly that, right? So perfect. It was able to get it for us, and it did so as the first item in the list. And what I want to do now is run the same exact question with our RAG agent. Let's see what we get in this case. So let's take a look at the logs once it is out. Okay, and where is the output? Pinecone output, and there you go, guys. So basically it came in as number 7 or something as the item in the list. So and this document is only 30 pages long. Imagine if you have a knowledge base with thousands of pages or tens of thousands of pages, for example, then using hybrid search would actually be tremendous of help. Now let's actually go to the execution logs so that we can understand what exactly happened in this workflow here. So we got our query, right? We got financial up 26.6 points. Then we generated the sparse vectors just like we did for when ingesting, and also dense vectors. Then this is the part where we are combining it into, can I convert it to a schema? Perfect. So this is now our schema. We're going to include metadata, top K, and then top K20, and then filter, which we don't add anything in. Then we go sparse vector, and then we got the vector and our namespace. This gets passed to this query vector store HTTP request node, and this is the payload that we send over to Pinecone. So that's the output that we just got here. So yeah, I hope you enjoyed this video and that this video was actually informative to you. But wait, we also have to fix this guy here as I remember. So I'm going to do something like this. All right, perfect. So we've sorted this problem as well. We basically this time just, again, get these chunks sorted and then send to this node here. And what this node is going to do, it's going to limit it to 96 items per batch. And then it's going to pass it to this aggregate node. This aggregate node is going to, again, aggregate up to 96 items, pass it to this generate dense vectors, generate sparse vectors, which later we'll just complete the rest of the loop, and our problem here is solved. So yeah, I hope this video was helpful to you and that you enjoyed it. Again, I'm going to be adding this template to my community, so definitely check it out. I hope to see you in. With that said, have a great day. Bye.